Good afternoon, dear student. In previous lectures, I was explained about type of relations and in which I explain all the definition and related examples. Examples are going on. Most of the questions taken from the relation reflexive, symmetric and transitive. The next example is the part 7 of lesson first, class 12. Check whether the relation R in R. Check whether the relation R in R. This R is set of real number. This R is set of real number and this R is set of relation. Defined as R equal to, this is R equal to A comma B such that this is a set of relation. A comma B such that A less or equal to B cube is reflexive, symmetric or transitive. It is given that R equal to A comma B such that A less or equal to B cube. A and B are the elements of set of real number. You know that to show the reflexive relation we have to take one element. If every element of set A related to itself, then we can say that the given relation is reflexive relation. You know the set of real number, there are infinite number of elements. So we cannot take one by one all the numbers and check it. So we take a particular number by the guessing which are satisfied or not. If you take 3 or 4 number, one by one you check, you definitely got the numbers 31. I take the number here 1 by 2. 1 by 2 is the element of set of real number. We see that 1 by 2 is not less or equal to 1 by 2 cube. But relation is given what? A is less or equal to B cube. It means A is less or equal to A cube. If satisfied this, we can say that the relation is a reflexive relation. Whereas we taking in place of A 1 by 2. 1 by 2 is not less than 1 by 2 cube. This implies 1 by 2 comma 1 by 2 not belongs to R. So R is not reflexive. Some student ask me that, sir, there is one element 1. 1 satisfied this relation. 1 is less or equal to 1 cube. So the relation should be reflexive relation. To dear, keep in mind the reflexive relation tell that if all the elements of the given set are related to itself, then we can say that the relation is reflexive relation, otherwise not. Here, the given set is set of real number. You check each and every element. This satisfied the rules of relation of reflexive or not. You got there are so many elements in set of real number which not satisfied this relation. So whenever all the elements not satisfied the relation, we cannot say the relation is reflexive. So this relation is not reflexive. Similarly, we take two elements 1 and 2 belongs to set of real number. Because to show the symmetric relation, we have to take two elements, two arbitrary elements. So I taken over here 1 and 2. 1 is less or equal to 2 cube is true. That is 1 comma 2 belongs to R. But 2 is less or equal to 1 cube is not true. Is not true. Is not true. That is 2 comma 1 is not the element of set of real number. So R is not symmetric. So R is not symmetric. Now, for the transitive relation, we have to take 3 elements. I take in place of A 3, in place of B 3 by 2, and in place of C 4 by 3. This is not a particular rule to, there is no particular rules to take these numbers. Just you have to check it one by one, which are satisfied or which are not satisfied. You have to check. Maybe there are so many numbers which are satisfied this, but we have to check all the elements. We have to check those elements, those numbers which are not satisfied for that. If you remember it, A is less or equal to B Q relation and A is less or equal to B square relation, you got there, this relation is neither reflexive nor symmetric nor transitive. So you have to choose those numbers which are not satisfied. For this you have to do the practice, then you can solve this type of problems. So we take 3 elements. 3 is less or equal to 3 by 2 cube, it is true. 3 by 2 is less or equal to 4 by 3, this is also true. But 3 is less or equal to 4 by 3 cube, it is not true. That is, A is less or equal to B cube and B is less or equal to C cube, but A is not less or equal to C cube. This is the definition of transitive relation. A related to B and B related to C. This implies A related to C. Or you can also say that A comma B belongs to R, B comma C belongs to R. This implies A comma C belongs to R. Then we can say that the relation is transitive relation. Here we see that the relation is not transitive relation. Now the next part is we take another examples by which you can understand better way. Suppose that L is the set of lines. L is the set of lines. And we find a relation over here R equal to L1 comma L2 such that L1 is parallel to L2. For all L1 L2 belongs to set of lines. Let us check the reflexive. Reflexive relation. You know that if there are two lines, this is line L1 and this is also line L1. So L1 and L1 both are on the same line length. So if L1 is the element of L, this implies L1 is related to L1, that is L1 comma L1 belongs to R, so R is reflexive. For symmetric, let two lines L1 and L2 which are belongs to set of lines L. See over here, These are the two lines L1 and L2. L1 is parallel to L2 and L2 is also parallel to L1, that is L1 comma L2 belongs to R and L2 comma L1 we can write over here implies L2 comma L1 also belongs to R. So R is symmetric. Now for the transitive, let L1, L2, L3. We take the three elements L1, L2, L3 belongs to a set of lines. L1 is parallel to L2 and L2 is parallel to L1 is parallel to L2 and L2 is parallel to L3. This implies L1 is parallel to L3. That is L1 comma L2 belongs to R and L2 comma L3 belongs to R. This implies L1 comma L3 belongs to R. So R is transitive. Since this relation is reflexive, symmetric as well as transitive, so we can say that relation R is in equivalence relation. I hope you understand this problem. Next problem is perpendicular. This is the perpendicular. It means two lines are having a relation if they are perpendicular to each other. If two lines are having a relation, it means both are perpendicular to each other. Let us see. First of all, reflection. Let L1 belongs to L. आप खुद बताओ क्या कोई लाइन खुद के परपेंडिकुलर हो सकती है? नहीं हो सकती है। तो L1 not related to L1, or you can say that L1 comma L1 not belongs to L. So not belongs to R. So R is not reflex. Symmetric. For symmetric, we have to take two elements. Let L1 comma L2 belongs to L. Suppose that this is line L1 and this is line L2. Both have the relation, both are perpendicular to each other. Here L1 is perpendicular to L2. This implies L1 comma L2 belongs to R, and this implies L2 is also perpendicular to L1. This implies L2 comma L1 also belongs to R. So R is symmetric. Now for the transitive. Transitive. To show the transitive, we have to take 3 lines. Let L1, L2, L3 belongs to L. See over here. L1 is perpendicular to L2 and L2 is perpendicular to L3. Here L1 is perpendicular to L2 and L2 is perpendicular to L3, but L1 is not perpendicular to L3. By figure you can see L1 is perpendicular to L2 and L2 is perpendicular to L3, but L1 and L3 are parallel, not perpendicular. That is, here L1 comma L2 belongs to R, L2 comma L3 belongs to R, but L1 comma L3 not belongs to R. So this relation is neither reflexive nor transitive, but only symmetric. If anybody asks you, give an example of relation which is neither reflexive nor transitive, but it is symmetric. So at this type of examples, in place of, you can take this example. This example is very easy and you can show graphically how this is possible. So thank you.